Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I will discuss about the solid residue generation, characterization and treatment from an incinerator plant. So which type of solid residue that has been generated, and then what is its characteristics and what treatment should be followed for this flue gases, okay, from an incinerator plant. So now let's start the lecture with this functional element of MSW. So in this lecture series of this solid waste, functional element of MSW are there. In MSW, Municipal Solid Waste Management System, Municipal Solid Waste Management System. First step is like I have discussed about the waste generation. First, this is the whole picture that is related with the municipal solid waste. From the waste generation, primary collection will be there, and then it's handling and storage. After handling and storage, next point will come, that is called a secondary collection. So from secondary collection, which type of transfer and transport methods has been adopted, and next is like secondary collection is the processing and transformation of MSW. So processing and transformation of MSW, and after the processing of this solid waste and its transformation, disposal will be there. So processing and transformation will require which type of methods will be required and what will be there into that, because in last lecture I have discussed you about this flue gases that is coming from the incinerator plant. So today I will discuss about the characteristics of these flue gases, its a treatment only also. So which type of residue that is coming from an incinerator plant. So from an incinerator plant is there, that incinerator plant we will burn all the toxic gases, all the toxic MSW. By the burning of toxic MSW, this type of residue will come. So that residue first is like bottom ash is there, that is slag, then grate sifting, then boiler ash, economizer ash, fly ash and acid gas cleaning residue. So bottom ash will be there, some that will be collected in the bottom of the tank, that is also called as slag. Then grate sifting will be there. Grate sifting is like that will be sift from one area to another area. Then boiler ash. In the boiler, when temperature will slow down, temperature will less, then some ash will be created. Then economizer ash is also there. Fly ash is also there. Then flue acid gas cleaning residue. So this is in this picture. Here boiler ash will coming out and bottom ash is going to be collected. Flue gas plus fly ash is there. And will feed the solid waste from here, MSW from here, and then after passing through the grate sifting, some bottom ash will be collected and some boiler ash will be collected. Then, so this is a picture that is showing the residue generation, how this residue will be generated. Boiler ash will be the residue, then bottom ash through the grate sifting, MSW will come, flue gas plus fly ash will make a bottom ash. And then in the fly ash that is collected in the bottom is called as bottom ash, and it is coarse in nature. Okay. So, first of all, we'll discuss about this bottom ash. It is formed and transferred to the combustion chamber on a moving grate and sometimes through a rotary kiln and the quencher. So, it will be formed and transported through the combustion chamber onto the moving grates, and it will be collected through the rotary kiln and the quencher. When the bottom ash leaves the grate of the rotary kiln, it must be cooled down. So, it should be cooled when it should leave the grate or the rotary kiln. Most commonly, the bottom ash drops from the grate or the kiln directly into the quenching tank with the water. That is called as bottom ash. It will be formed and transported through the combustion chamber on the moving grate and sometimes through a rotary kiln or to the quencher. When the bottom ash leaves the grate or the rotary kiln, it must be cooled, and most commonly the bottom ash drops from the grate or the kiln directly into the quenching tank with water. So this is the fate of this bottom ash, that is called as slag also. It is mostly formed and transported through the combustion chamber on the moving grate and sometimes through the rotary kiln and the quencher. When the bottom ash leaves the grate or the rotary kiln, it must be cooled down. It should be cooled down when it will be leaving its chamber, and the bottom ash should be drops from the grate and the kiln directly into a quenching tank with the water. And now next is the like a boiler ash. Boiler ash are those ash that will be collected from the boiler. So after this hot chamber, this flue gas will enter into the boiler a boiler. So in boiler, what happened? It consists of the material that is removed from the flue gas at the cooler surface of the boiler and other heat transfer equipments. So it consists of some of the materials that is removed from the flue gas at the cooler surface of the boiler and other heat transfer equipment. The material that condenses on the surface act as an insulator, reducing heat transfer rates, and must be removed at regular intervals to maintain process efficiency. The material that condenses on the surface act as an insulator. This actually what happened, in this boiler, it will be like cooler surface will be there. So that cooler surface of the boiler and other many heat transfer equipments has been installed. The material that condenses on the surface act as an insulator. This material that is going to condense the surface of the boiler, it acts as an insulator. So insulator, it will works to make it cool down and reducing heat transfer rate, and must be removed at regular interval to maintain process efficiency. So it must be removed at the regular interval to maintain the process efficiency. So like this, the boiler ash will be there. And now next point is like that, grade shifting. Grade shifting, in grade shifting, what happened? The bottom ash will be passes through the opening in the grates, either due to the size or because it will melt down. So like this grate are there, you can see in the picture. So what happened? The flue gas will passes through the opening of the grate, either due to size or because it melts and is trapped in the under fire air plenum located below the grate is referred to as grade shifting. Located below the grate is referred to as a grade shifting. So combustion grate through which is shifting pass. So combustion grate are there which will be going to be shifting the pass, and this is like it passes through the opening in the grate either due to size or because it will melt and is trapped in the under fire or air plenums. It will be trapped under the fire and air plenums, and it is located below the grate is referred to as a grate shifting. So it is going to located below the grate and it will act as a, it will be work as a referred to as a grate shifting. So these plenums located below the grate is referred to as a grate shifting. Then what happened? It passes through the opening of the grate either due to size or because it melts and is trapped in under the fire air plenums located below the grate. And the combustion grate passes, which is the shifting pass only. So like this grate shifting will work. Next is like economizer ash. So final particle. Economizer hooper will be there that will be going to collect the fly ash, little fine particle of ash. So the final particle collected from the flue gas in the economizer or some hooper are there that is installed in some boiler system to optimize the recovery of heat from the flue gas before the gas is subjected to a more through the treatment. So the finer particles are there, very small dust flue gas particles are there that is collected in the hooper and that is installed in the some boiler system to optimize the recovery of heat from the flue gas before the gas is subjected to a more through the treatment. And economizer hoopers are there that is going to collect the ash. So these fine particles are there that is collected from the flue gas in the economizer. This is economizer is nothing but a hooper is there. So you can see in the picture the hooper is there. That hooper is collecting the fly ash, the flue gas particles into the boiler system because it all will originate into the boiler when the temperature is going to be cooled down. So after the cooling of the temperature, this will be going to collection to optimize the recovery of heat from the flue gas before the gas is subjected to a more through the treatment process. So what happened? Then next is the fly ash. Fly ash is a very fine particles that entrain into the flue gas from the boiler and recovered in the electrostatic precipitator or fabric filter. So it will comes from the acid gas cleaning residue also. Solid residues and the wastewater generated during the treatment to remove acid gases from the flue gases. So fly ash is like a, we can say that fly ash is a very small fine particle that will comes from the flue gases from the boiler and it will be recovered, it will be collected into either in the electrostatic precipitator or in the fabric filter and acid gas cleaning residue. So what happened? Solid residue or the wastewater generated during the treatment to remove acid gases from the flue gases. So you can see that fly gases are stored in the bags because these fly gases are generated in a more and more amount. Because what happened after the incinerator plant, when it will be going to be cooled down, obviously all the waste, these flue gases will be going to be cooled down. Very small ashes will be collected into the bottom chamber. That is called as fly ash, and then it is going to be, this fly ash is a very much dangerous, and it is a very fine particle. By a very fine particle, it can be easily dispersed into the atmosphere, or it can be a kind of a solid waste nowadays, because the management of fly ash is now very tough. How to manage this fly ash? Because the fly ash management is now required a lots of attention, because fly ash will be easily dispersed into the air. It will be easily dispersed into the soil, so that it will be creating some air pollution also. Sometimes what happens, fly ash from the soil during the rainy season, due to the leaching, it will enters into the groundwater. So this fly ash will contribute toward the water pollution also, groundwater pollution also, air pollution also, solid waste management problem also. So this fly ash is like a very big issue, and it is generated anytime. This residue is generated either from the wastewater generated in the treatment to remove acid gases from the flue gas. Now comes to the generation of residue. This is the data that is related with the generation of residue. Typical amount of various residues produced per tons of waste incinerated in modern state of art, that is mass burn incinerator. So type of residue, like first is like bottom ash. Bottom ash is approximately this amount of ash is produced. Like typically amount produced is like 150 to 300 kg per tons of the waste is producing. In grade shifting also approximately 5% in the boiler ash also. So flue gas cleaning system through the dry process, semi-dry process, wet dry process, means you can see that the amount of production of waste, this typical amount of production of waste is very high, that is, and mostly from the bottom ash. So this bottom ash will be collected into the bottom of the chamber, and this ash is now to minimize and to management of this ash is very problematic. So various residue produces per ton of waste incinerated in modern state of art mass burns incinerator. Now this is the picture, that is a characterization of the residue. Actually, this residue characterization is very important. So first of all is the bottom ash is there, chemical composition of bottom ash and chemical composition of fly ash. So you can see that in the bottom ash, all useful elements are there. Elements in the bottom ash is there: oxygen, silicon, calcium, iron, aluminium, sodium, potassium, carbon, magnesium, sulfur, phosphorus, copper, zinc, chlorine, lead, manganese, PCB, pH, all are there. So up to oxygen to manganese, sulfur, phosphorus, copper, they are comes under the up to some limit. It is called as a essential element. Essential element. But these are sometimes up to zinc also. But chlorine, lead, manganese, PCB, pH are the toxic metal. They are the toxic element. They are the toxic element. Like that in case of chemical composition of fly ash. So in this way, we can see that the bottom ash and fly ash will contain many useful elements also. It will have some essential elements also and some toxic element also. So these toxic elements are very much dangerous, but these essential elements are very much required, and it should be required for the generation of a plant also, because this bottom ash will have some essential element and like that some toxic element also. Like in case of fly ash also, you can see that elements up to zinc, these are the essential element, means this will be required by a plant. But lead, manganese, PCB, they are the toxic element. They are the toxic element. So this is the characterization of residue. We have discussed the residue that has been generated from the flue gas and what is its chemical composition of the bottom ash and the chemical composition of the fly ash. So you can see that the range of silica is less in the bottom ash, but in fly ash it is more. Like calcium is again less, but in fly ash it is more. So all the elements is very less in the bottom ash, but it will be increased into the fly ash. Like that in case of toxic metal, toxic elements also. In this way, we can say that this bottom ash and fly ash will have both type of characteristics. Like it will contain some essential elements as well as some toxic properties also. Now, we'll discuss about what are the problem that has been associated with the MSW incinerator ash. So, due to volatilization and subsequent condensation as well as concentration phenomena which is acting during the combustion, MSWI residue have high concentration of heavy metal, salts as well as organic micropollutant. So, what happened? Volatilization and subsequent condensation as well as concentration phenomena acting during combustion, MSWI residue have high concentration of heavy metals, salts as well as organic micropollutant. The fly ash is problematic for incinerator operation and can cause a slagging and falling in addition to environmental issues. The fly ash is problematic for incinerator operation and it is going to cause slaggings and falling in addition to environmental issues. And the fly ash contains some heavy metals and high contents of easily soluble salts. In some cases, PCB, polychlorinated dioxin and phenols also having. So, fly ash will contain some essential elements also as well as some soluble salts and like some PCB, polychlorinated dioxins and some furans also. So, like that, these are the problems that has been associated with the MSW incinerator residue. It will contain some high toxic chemicals and some easily soluble salts also. And basically fly ash is problematic for incinerator operation and it will causing some slaggings and falling in and it will contain some environmental issues also. So these are the fate that have been related with the MSW incinerator residue. So this MSW incinerator residue should be treated properly before it will be enters into the atmosphere. And the next point is that the quantity and quality and characteristics of MSWI residue depends on many factors like composition, and incinerator type, and next is like operating parameters, pollution control techniques. So it will be depends upon the composition of feed, type of incinerator, operating parameters and pollution control techniques. In some European countries, great efforts are devoted to for the utilization of such residue through various treatment process. So if utilization is not possible due to regulatory constraints or any other reason, these residue has to be disposed in an environmentally acceptable and economically sustainable way. So this has been given in the policy, like if utilization will not be possible due to some regulatory constraint or any other further reason, the residue has to be disposed in an environmentally acceptable and economically sustainable way. So this is the I have discussed you about the fly ash, how much this fly ash is the problematic for the environment. Fly ash will be having a very small air dispersed particle. It will causes air pollution, soil pollution, solid waste management problem also. So it should be treated when it will be collected into the hooper or into the chambers. So fly ash treatment is very much required, and these are the very big problem that has been related with the this incinerator process, burning of incinerator process. So the quantity and quality and characteristics of MSWI residue. The MSWI municipal solid waste incinerator residue will be there. That will be depends on the some factors. Factors like the composition of the feed, means which type of waste that has been used in this incinerator, and what are the type of incinerator, like a rotary kiln incinerator is there or kiln incinerator is there. So the type of incinerator, composition of the waste, and the parameters that has been operated. Parameters that has been operated during the whole process is a very important factor. And the pollution control techniques, means which type of techniques is followed. Either electrostatic precipitator is there, or fabric filter is there, or bag filter is there. So like that, the quantity and quality and characteristics of MSW residue. The residue that has been generated in an incinerator plant will depends on many factors, and that factor is called as the composition of feed, means which type of waste has been used, what type of solid waste, MSW waste, is using in that incinerator. Like that, some type of incinerator and operating parameters. What are the different operating parameters? What are the different important factors that is going to be used into that particular incinerator process? So, and the pollution control techniques, which type of pollution control instruments is using in this particular incinerator plant. So these are the basic thing that has been required, that has been understand before knowing the quality of the fly ash, before knowing the what should be method should be adopted for the safe and safe utilization of the fly ash. So in some of the European countries, they are following a great effort devoted towards the utilization of these residue through various treatment. This residue means fly ash. So in India, this fly ash has been used into some brick making industries, into cement making industry. That fly ash has been directly imported to the brick making and cement making. But what happened? Because we are totally dependent on the electricity on the for coal-based thermal power plant, from this incinerator. So like that, too much tons of fly ash is generated every day. So what we can do to utilize this fly ash, because fly ash is a very small particle that can be easily dispersed into the atmosphere. Sometimes when we'll throw it onto a dump site, what happened during the rainy season, the toxic element is present in the fly ash will leach out into the groundwater. And third point is that it is a solid waste management problem also. So in this way, we can say that this fly ash is a very much problematic in nature. It is causing air pollution, water pollution, and soil pollution also. So this management and utilization of fly ash is very much important, because and nowadays too much amount of fly ash is generated. This is a very big issue. For every this type of plants are there, they have their own fly ash dumping site. But with that fly ash dumping site, that can be easily dispersed into the atmosphere. That fly ash is creating some of the air pollution. Sometimes what they are doing, they are making slurry of this fly ash by adding some of the water, and then they are disposing it into the pond in a nearby or vicinity of their industry. So in this way, what happened during the rainy season, the toxic elements will leach out and enters into the groundwater. It is going to pollute the groundwater. So in this way, this fly ash utilization is very tough, and it is not possible. If it will be not possible to a regulatory constraint or any other reason, the residue have to be disposed in the environmentally acceptable and economical sustainable manner. So to the management of fly ash, that much amount of management of fly ash is now very tough, because then only we can adopt some of the plant-based method to clean this fly ash, to working on this fly ash. Then what happened? We will go for the process of phytoremediation. On the fly ash dumping site, when we will plant some of the local species of that particular area. So what that plant will do, if we will plant some of the plant on some local species to that fly ash dumping site, that species is going to be will grow onto that area, because they are like resistance to that place. So with the resistance, that particular species can grow on the fly ash dumping site. In this way, we can remove the pollutants from the fly ash. By removing the pollutants from the fly ash, the plant can be harvested, because the pollutant, the toxic metal that are present in the fly ash, that can be uptake by the plant only. So by uptaking that heavy metals into the plant, by taking that toxic metal into the plant is going to be stored it into its harvestable part. And the one more thing also related with this, that plant cannot be eaten by the cattle also. So some local species, some wild species are there that are exotic in nature, so that cannot be eaten by the cattle, that cannot eat by the local cattle. So in this way, this is the safe utilization of fly ash. So this type of phytoremediation or phytoextraction method we can adopt to utilize this fly ash, to make this fly ash free from pollutants. So when we will make this fly ash free from pollutant, then we can use this fly ash to the agriculture field, because this fly ash will contain many essential elements also. So to utilize this essential element, we can use this fly ash in the agriculture field, and in this way the heavy metal cannot enters into the food chain of the plant. It cannot be enters as a food chain into the food chain of the agriculture crops. So this is one of the method that we should adopt to clean, to make it to make this fly ash free from air pollution, free from pollutant. Okay, this should be a very good method that should be adopted to clean this fly ash. And this fly ash is now a very much problematic from the incinerator plant, from the thermal power plant that are generated in a huge quantity, in a too much quantity. So utilization is very tough and it should be not possible. So as it has been said that if utilization will not possible due to some regulatory constraint and some other reason, this residue has to be disposed in an environmentally acceptable and economically sustainable manner. So utilization of fly ash by the process of phytoremediation into agriculture feed can be a economically and sustainable way to clean out, to utilize this fly ash into a agriculture field or some of the garden. So the utilization of fly ash is very much required because it should be a need of the present generation. So this is the references of some of the textbook that you can go further for the further study of these topics. So in this topic, I have discussed about the incinerator plant and what are the residue that is generated from an incinerator plant. Because what happened, the residue is the main thing, and what are their characteristics and what are their basic function and what are the negative point that is related with this incinerator plant, and the residue that is generated from the from this incinerator plant, how that can be managed or utilized, and what are the methods should be adopted to utilize or to use this incinerator waste. And this because nowadays most of the solid waste transformation can be took by incinerator only, and solid waste will have very toxic chemicals. So when it will comes to the burning, during the burning it will be burned out, but when it will enter into the boiler, when the temperature will be cooled down, ash is producing. So this ash is now very much problematic, and to management of this ash is too much required. So this topic is all about the management and characteristics and treatment of this flue gas, how this flue gas is treated and what are its characteristics. So for this lecture, if you have any query, if you have any confusion, you can mail me into this given mail ID, that is Shikha, SHIKH, shikha.pandey@gmail.com. You will write me your query, and if you want to study further, you will go and study the incinerator plant which has been adopted for which type of industry, and what are the different parameter and composition of the solid waste that has been producing which type of waste, and that has been producing which amount of this flue gases, what are the amount of flue gases has been originating. Okay. So I will conclude my lecture here on this point, and I want to next class I will discuss about the incinerator process, which type of incinerator has been used, and previously I have also explained to you about the flue gas characteristics and which type of instruments like this bag filters, venturi scrubber, electrostatic precipitator has been installed. So thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.